Let me get started here. I'll begin with a word of prayer once I get up here. Dear Heavenly Father, we thank you for this day. Again, I thank you for this class. Just ask you just guide our steps today, help us to glorify you in what we do, and just to enjoy your creation together, Lord. In your name I pray, Lord Jesus. Amen. Amen. So, the name of the game with all these kinds of problems is basically to eliminate the denominators. Like, you want to get rid of the denominators in some way or another. And so basically my method for solving these, by and large, is to just look at the denominators that I have and multiply by that. And that makes it into something we already know how to solve. So this problem, if I just multiply by x minus 4, then what happens? Notice we have to distribute here. Right? So, yes, Michael?
So we need to eliminate the in each side. Put x equals 4 plus 4x minus 4. And move 4x minus 16.
Right.
And then you combine like terms. And move them to the other side.
Okay, so we get, let's see here, minus 3x equals to minus 12.
And divide, and you get x equals x equals 4.
X equals 4, that's right. Now, but what's the problem, Michael? Is there a problem?
So excited that I just did right through it without even noticing my mistake.
I don't think it's a mistake yet, but in these problems, the thing is, when you multiply by x minus 4, there's one case where you're changing the solution set, when you're trading the equation you have for a new equation which is not the same. And that one case is when x is equal to 4, right? When x is equal to 4, we're multiplying the equation by 0, which means you're destroying all the information in the equation, basically. Anyway, long story short, we have to check our answers and make sure that they make sense for the original problem. Does that make sense for the original problem? What happens when you plug 4 into the given equation? Yeah, we get division by 0, right? So
no solution.
This is an extraneous solution. Extraneous, which means that it's not even in the solution set. So solution set is empty. There is no solution here. So I often tell students that, like, you know, if I was to be a rapper, then I would be known as extraneous G, and my tagline would be, I'm not even in the solution set. It's just like this. So there you go. I've been waiting all semester to tell you this, but it finally happened. All right. Anyway, and I orchestrated it to happen on CFA Day too, right? There we go. Actually, that's an accident. But anyway, how about the next problem? How do we solve this? Should we multiply by x? Should we multiply by x squared?
Multiply x times x.
Multiply by x squared it is, yes. So x squared times 7 over x squared plus x squared times 19 over x equals 6x squared. So this gives me 7 plus 19x equals to 6x squared. Bring everything to one side. We get 6x squared minus 19x plus 7 equals to 0. And then these problems usually can be factored because I'm pulling it out of the book, right? In the wild, if I just make a problem up, you're going to need to use completing the square or the quadratic formula. But odds are pretty high that this can be factored. Yes, sir?
Minus 7.
That's a good question. Why isn't it minus 7?
6x squared and 7 on opposite sides.
Yeah.
So if we put them on the same side,
right.
7 would have to be minus.
So are you saying I'm wrong?
Yes.
Okay, good. Very good. Very good. That's what I was hoping for. Have confidence in yourself. Yes. Of course, I made that mistake on purpose for the sake of the CFAWs, so that they could appreciate the interaction of the class. You know. That's right. Oh no. Oh no, Holly has seen through my subterfuge. Oh no. All right, let's see here. So 7, I think we want a 7 and a 1. That's pretty much it. And how about the 6? I need to get a 19, right? So I'm thinking we want a 3x here, and we want a 2x there, because then I get a 21 and I got a 2. And I just need to make the 21 negative, and I make the 2 positive. So I believe that'll do it. We haven't done a lot of factoring like this up to this point in here, right? In fact, this wasn't really an issue on my test at all, was it? No. The factoring you faced on test 1 was not like this. But this does happen, and so we should talk about it. Here it is. You know, you could complete the square to factor this, but I don't think that would be the right approach here, right? If you can see these kinds of just shifting numbers around, adding the coefficients up to match like you want, that's great. Okay, so then what are my solutions? So we either get 2x minus 7 equals to 0, or 3x plus 1 equals to 0, which gives me 2x is equal to 7, or 3x is equal to minus 1, also known as x is equal to 7 over 2, or x is equal to minus 1/3. So them's your solutions. Now, how about this time? Is there anything extraneous here? What would be extraneous for this problem?
0.
0. Are those 0?
No.
So, answers. All right?
Here are the answers, like you talked about.
That's right, Michael. Let's see here. So example 3. We could face something like this. X plus 4 over 2x is equal to x minus 1 over 3. It's important I copy the problems down from the book, because if I just make them up, then the answers aren't pretty. Well, sometimes they are, but... So can you guys solve that? This one I adopt a different approach. So I use what I call cross multiply here as a method. What's the cross multiply method? Let me just comment on the generic pattern here, if you don't know it already. If you're up against something of the form like a over b equals to c over d, a nice approach is just to multiply d over to a and multiply b over to c and solve this equation instead. So that's what we're going to do. So cross multiplication gives me 3 times x plus 4 is equal to 2x times x minus 1. This is logically equivalent to simply multiplying by the product of the denominators. If you want to think of it that way, you can, but I like to think of it as cross multiplying. It's just a nice tool to have in your algebra kit. Now, can we solve this? I hope so. Yes, Michael?
We're not done yet.
Oh, we're not done yet.
We still need to distribute and divide and make sure the a is positive.
3x plus 12 is equal to
2x squared.
2x squared minus 2x. And you said make sure the a is positive. I like what you're saying. I think it's a good strategy. Move everything to the side where x squared is positive. So I'm going to keep my 2x squared and minus 2x minus 3x minus 12 equals to 0. So what I've done is I've moved everything over to the right-hand side of the equation. Now we collect like terms, and then we have faith in the book giving us a nice problem to factor. So nice things are going to happen again. I can feel it. Can you feel? I feel like a 3 and a 4 are coming on. I feel a 2x and an x. Now, if that's it, I got lucky. Oh yeah. So That's a minus, that's a plus. I think we're good. I was just guessing. Yep.
Does it matter which like factor the 2x goes on?
Yes, it does. If you tried something else, like this, you could try that out, and you'd get like a 6x, and then plus a 4x, so you could achieve a 10, or you could achieve a 2 with like 10 minus 4, 6 minus 2, 6 minus 4. And these don't give you the patterns that you need for that. So indeed, and it's worse. No, I guess that's about it. No, it's worse, because you could also think about like x plus 3 times, you could put a 2 here, and you see you could put a 2 here, and you could put a 6 over here too, right? Because 12 is also 2 times 6. And by golly, it's worse than that, because you could also think about, like 12 and 1 here. There's many, many options in the factoring by guessing game, which is why I said at the start of this, I got lucky. Because I didn't think about this, I just wrote these numbers down. You see, I was fortunate. And it wasn't one of these. Now, so the good news is, if you guys don't see the factoring, there is a way out, a way that always, always works, which is to do what? Complete the square. Completing the square. So what that looks like here is we've got 2x squared minus 5x plus minus 12, right? And if I was to complete the square there, I would, first of all, I'm solving an equation, so I'll just divide by 2. And then I would do x minus 5/4 squared minus 25 over 16. Now 6 is 6 times 16, which is 96 over 16. So, of course, you might need a calculator. 121 over 16. And so x minus 5 over 2 is plus or minus the square root of 121 over 16, also known as plus or minus 11 over 4. I feel like I made a mistake. Yes, I did. I had a 5/4 here, and I somehow dropped it and became a 5/2, which of course is nonsense. That should have been a 4. That should have been a 4. And so what solutions do we get? X equal to 5/4 plus 11/4, or x is equal to 5/4
Excuse me.
minus 11 over 4.
How did you get negative 90? Negative 96.
6. Well, that's 6 and 16ths. 6 times 16 is 60 plus 36, which is 96.
Oh.
That's how I think about it.
I thought it was negative 25 over 16 minus 12.
But we divided by 2. I divided by 2
Since the whole equation was divided by 2, it's minus 6
Oh.
instead.
to make my life easier slightly. And so what does this work out to? Well, what's 16 over 4?
Let me take a picture.
Go for it, Michael. It's x equals to 4, or x equals to what? What's 5 minus 11? Minus 6. Minus 6 over 4 is minus 3/2, right? What do you know?
Nice.
Isn't that what we
That's what I had.
got over here? See, this equal to 0 would also tell you either x is equal to minus 3/2 or x is equal to 4, right?
Oh. Instead of erasing it, I can write
Does anyone have another way you would have solved this equation besides the lucky factoring? Obviously the easiest, right? Lucky factoring is the easiest. Completing the square, a little bit intense, yeah.
Can we do the quadratic formula?
You could do the quadratic formula if you did it correctly, right? So yeah, you could use the quadratic formula. You could even, like, if you have the right calculator, there's a quadratic formula solver in the calculator, right? It's in there. I think, Michael, you have the what? The TI-36 x pro or something.
Yeah, 36x Pro.
Yeah, that one will solve quadratic equation, for example. My ancient version of the Casio, oh man, well, I don't have it with me, but my Casio will do it. Anyway, the good news is there is an objective reality. There is one answer, right? Your life experience, your life story will not change this answer. There's no postmodern mathematics. It's just there's like an objective reality you're going to find. So, sorry if that offends your, philosophical sensibilities, but 'tis what it is.
Today I feel like 2 plus 2 is 5.
You feel like 2 plus 2 is 5? Well, math doesn't care about your feelings. 2 plus 2 is still 4, except for exceedingly large quantities of 2. Let's see here. Would you guys like to work another?
Oh,
Sounds good to me.
of course.
Okay.
I'm all ears.
You're all ears. All right, this will be our final equation of these sorts. So example 4, we could have something like, oh goodness gracious. Yeah. X over x minus 3 plus 3 over x minus 3. I lost my place. Equals to 3. Let's look at this one. Now here guys, I'm going to use a different approach. I'm actually not going to use the method I've used in the last few examples. Here I'm going to just make an algebra step and observe something. All right? So just focus on the left-hand side. Do you see how we can make that into one fraction? Right? X, what do you say, x plus 3? Oh, man.
Oh,
I'm sorry. I reserve the right to change the problem. Sorry, Michael. I'm going to change the problem, Michael. Michael, I'm changing the problem. I'm making this a minus. Okay? It's for a good cause. So what happens with that minus is we get this combines to be what? X minus 3 over x minus 3 equals to what? This equals to 3, right? But what is x minus 3 over x minus 3 equal to?
1.
It's equal to 1.
Oh no.
So 1 equals to 3, right?
Yes.
No.
No, right? That's
Maybe in postmodern math.
in the postmodern mathematics, sure, but this is decidedly unpostmodern college algebra. So we're going to have to accept that this is an absurdity, and so that means that
Extraneous solution.
not even that. There's just no solution here at all. But yeah,
If it's 0, it's extraneous. If it's a number, then no solution.
right, no solution here. So we usually say extraneous if the method of the algebra produces some solution for us, but then that solution isn't actually a solution. That's when we call it extraneous. So that there was no x equals something here, so that's why I wouldn't say extraneous. Like in the previous one, we were led to be tempted to think like, in example 1, we had x equals to 4 was what the method seemed to suggest, but that actually wasn't a real solution because it's not in the domain of the original function, the original expression.
Oh,
Okay, so of course we could do more of these, but I think I probably need to focus more on the problem of inequalities with you guys. So we're going to go on to that. We're going to look at rational inequalities. How do you solve rational inequalities?
excuse me, Professor.
Uh-huh.
Does this mean that you could add more problems on the mission?
You want me to add more problems on the mission?
No. Highlight more problems. That's what I meant.
Oh, highlight more problems. Possibly, Michael. All right, so hey, guess what? I found my handy dandy attendance sheet
Yippee.
because I finally cleaned my office today. It's very exciting, yes. So as such, let's hand it around. What do you guys want today's date to be?
Thinking it's the 23rd.
Oh,
It's the
attendance
23rd?
sheet.
Yeah,
Attendance
End
sheet.
of the year.
I want to drawing them.
so there you go.
Exactly a fun.
All right.
The day after.
All right. So let's talk about inequalities. So you might call these rational inequalities. I'm not sure that's the right title here, but it's a title. And so what I'm talking about is inequalities involving rational expressions. All right? So let me show you the method. I'll start out with one that's kind of already ready-made for us. It's going to be kind of complicated, so hang with me here. X plus 10 times x plus 6 quantity squared times x minus 4 cubed divided by, let's say, x to the fifth times x plus, oh, I don't know, let's say 3, and then times x minus 7. That seems pretty horrible. I think that's more than enough for us to chew on. And, well, I'll let you guys pick. Greater than or equal to 0 or less than or equal to 0?
Which one's easier? Which one's harder?
They're of equal difficulty.
Less than.
Less than. Michael is the decider. Less than or equal to 0. Very good. So, now what?
Factor out the equation.
The good news is you're right, but the bad news is it's already done. Wait a minute, that's also good news. The good news is it's already factored. And there's no common factors either, right? You got the 10, the 6, the minus 4, the 5, the 3, they're all different, right? So we need to identify the critical numbers. Now critical numbers come in two varieties. The critical numbers for the numerator, the critical numbers for the denominator. Critical numbers for the denominator are outside the domain of the expression. We simply cannot evaluate at those numbers because it would give division by 0. Critical numbers for the numerator, that's fine. It just makes the fraction 0. So if you plug a 0 into the top of a fraction, it just gives you 0. That's fine. So critical numbers, it's important to list them in order, right? Which is the smallest one? This would be 0 when x is minus 10, right? What's next? Negative 6. What's next? That would be positive 4 because it's x minus 4. So this is 0 when x is minus 3. That's your 0. And what else we got here? I heard a 4. And finally 7. Did I miss anything? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, yeah. Now what? We draw a
Drop
number line. That's right. And you put a tick mark at each one of these numbers. Minus 10, minus 6, minus 3. I don't really care if these are like to scale or anything. All right. I'm not so worried about them being accurate to the where they should be on the number line. I just want to make sure that they're separate. I can read them clearly because this is just a device to keep track of where there's plus and minus, right? Where it's positive and
I'll
negative.
need to find the numbers between.
Yeah, well, actually, remember we learned the sign flip theorem? So it's enough to figure out what the sign of the expression is one place. And then we can propagate from there. So for this one, what I usually do is I think about plugging in something big. Because it's easy to think about a big number. In this case, what's a big number? Maybe 10? Yeah, like that. 10 is good. If I plug 10 in, that's positive. That's positive. 10 minus 4, positive. 10 to the fifth, positive. 10 plus 3, positive. Yeah, positive. 10 minus 7, positive. So if you got plus, 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 it is
Positive.
positive, which earns us a plus over here. Then we're going to use the sign flip theorem. 7, the multiplicity of the factor where the 7 critical number came from is 1. So I flip from plus to minus. How about 4? That's from x minus 4 cubed. That's also an odd power, so it also will flip signs from minus to plus. Okay? Now, what's up next? 0. What does 0 come from? X to the power 5, again, an odd power, so we flip signs. All right. Minus 3. Well, again, that's from an odd power, so we flip signs. Man, are we ever not going to flip signs? I should have made more even factors. My bad. Oh, here we go. Finally. Minus 6 comes from this. That has multiplicity 2. The factor does.
So stay the same.
Yep, stay plus. But then x plus 10 is again just linear. It's a one of them, so it flips from plus to minus again.
Odd.
Are we doing attendance sheet? Because I didn't get past it yet.
So,
I think you put it on your desk. Is it sitting up there on the right?
Ah,
Thank you.
killing me. All right, so less than or equal to 0. We're looking for where the signs are negative, right? So that's where? Here, here, and here. So my solution set is what? Yep.
negative.
Okay.
In negative infinity.
Yes, we are always writing it in interval notation.
U. Negative 3.
Negative infinity to minus 10. Now my question for you guys.
U.
My question for you guys is minus 10 part of the solution or not?
It's part of the solution.
What?
It is or equal to it.
Because we're doing less than or equal to 0. And does it make it 0? It does, because it's in the numerator. All right, so yes, we include minus 10, so we put square bracket there. Then I union with minus 3, because it's included. That's the
That's right.
minus 3 to 0. Now, how about minus 3? Is minus 3 included in the solution set?
Yes.
It is not, because it is coming from this division.
Negative 3 plus 3 is 0.
At minus 3, we have division by 0. That must be
Bracket.
excluded. Open parentheses, like that. Now, how about 0? Again, 0 has to be excluded because it's coming from this, which would give us division by 0. So we, again, exclude 0. What's next? 4.
4.
Do we include 4 or exclude 4? See, it's in the numerator.
But it's a division by 0.
Oh, no, there's no division by 0 at 4 because we just have, it's up top, so it's 0. So we include the 4, so square bracket 4. And how about 7? See, 7 again is coming from a factor in the denominator. We'd have division by 0 at 7, so we exclude the 7. And there it is.
That is a crazy answer.
If you understand this example, you can pretty much do any of these. Modulo the algebra. All right? You're like, but isn't this an algebra class? Yes, Michael.
Are drinks allowed in here?
Are drinks allowed in here? Well, that depends on what you mean.
Because I'm because I feel a little sleepy. I need to take a pill of no dose.
You may certainly drink if you need a drink. It's fine. Yeah.
It's not alcohol.
All right. So, what made this first example, well, my 5th example for today, but what made that easy is that I already had it factored. And I already had it all nicely arranged on one side of the equation, right? But that doesn't have to be like that, right? It could be It could be not already put to 0. It could be kind of more messy than that. Let's look at one. It's a little bit more messy. So here we go.
It's between, it's including
I can find my problems. So yeah, again, to review, the points that you include, so thought experiment. What if instead of less than or equal to 0, it was just less than 0? What would change? Yep.
I think that the solutions would change.
Yeah, the solutions would change. And so the simple thing that happens is if we change that less than or equal to less than, it just makes all the square brackets become parentheses because we don't allow 0. So we exclude all of the critical points. We never include critical points, which are from the factors in the denominator. Okay, if there's a factor in the denominator, that means that the 0 of that factor is automatically out of the running for the solution set because it's outside the domain of the expression. Right? There's no fixing it. Yes, sir?
Quick knowledge check. Well, -6 wasn't in the answer because the sign's the same between -10 and -3. It doesn't need listed, right? Like from the number line, because number 6 is...
Oh no, thank you.
Or do we...
Oh, good point, good point.
It wasn't my idea, it wasn't an original thought. I just spoke up.
Union what? No, thank you. That's very good. It just totally missed it. Man,
So when we list it,
now I got to go back and put the camera back.
when we list it after the -10,
Dang it.
like all the unions just slide to the right, it would be...
Yeah, so this is the kind of, this particular issue, I a lot of times don't take points off a student's test if they miss this, just because it's kind of funky. But I mean, technically I should, because this is incorrect as it was stated, because you're right. -6 is a solution to that equation, right? Because if I put -6, it makes it 0. 0 equals 0, true. So I have to take the union with the singleton. It's just a set just containing -6.
So you can just add it to the end.
Yep. But, so this is the thing, with interval notation, you do like that. If you want me to write it with intervals, do you guys want me to write it with intervals? You don't.
No.
But if you did, you could do something stupid like this. -7, -6, intersect, -6 to say -5. See, that would be equal to the set just containing -6. So in that sense, it's an intersection of those sets. Now I'm just wasting your time, so ignore me.
No, it's fine.
I'm just messing with you guys. We don't really talk about intersection in here much at all, do we? But that's the intersection of two. Intersection is the upside down U. That's when you're in both sets. The intersection of two sets is the points which are common to both. So if I look at the interval -7 to -6 or -6 to -5, the only thing that's common to both of those is just where they join together at the -6.
Oh, that makes sense.
Yeah. All right, let me go on here. Yes, Michael.
How did you get -6 also as a solution?
Because if we plug in -6,
-6 is a critical number that
it equals
can't be
0.
equal to 0, therefore it has to be listed in solution.
But how come you didn't put the rest of the numbers
Because we
in?
forgot about it.
The truth is human error.
Because the other numbers are already in. We already have -10,
It would be a waste of effort.
and we already have -10 here. We already have 4 here. The only critical number upstairs that we're missing was -6. It just so happened it wasn't.
So 10, 0, 3, 4.
All right, so here's one. We could study 3 over x minus 2.
Thank you.
You're welcome. Less than 1. So let's see here. So I would say, okay, well that is 3 over x minus 2 minus 1 less than 0. Now I need to make it into a single fraction for our method to work, okay?
Whoops.
So how would I make that into a single fraction? I make a common denominator. The common denominator I would make would be, well, x minus 2. So I have 3 minus parentheses x minus 2 over x minus 2. That's what I would do. So I make a common denominator. Basically what I'm doing is I'm just multiplying I'm multiplying minus 1 by x minus 2 over x minus 2. And how does that simplify? Well, this simplifies to 3 minus x plus 2 over x minus 2 less than 0, also known as 5 minus x over x minus 2 less than 0. So this problem is both harder and easier than the last problem, right? It's harder because there's a little bit of like formatting we have to do of the expression before we can start the number line method. Do you guys not follow me?
Oh, I thought negative 1 jumped to the divide by negative 2 as in.
Let me do an in-between step here. So what I'm doing is 3 over x minus 2 minus 1 times x minus 2 over x minus 2, which is 3 over x minus 2 plus, well, rather minus, x minus 2 over x minus 2, but then I can combine them.
Yeah, okay, that makes sense. That tracks.
Which is, of course, then 5 minus x over x minus 2. So that's how that happened.
Let me write this down.
Go for it. So guys, what are my critical numbers for this one? I heard a 5.
Positive 2.
Positive 2. Sounds like a plan. So my number line, I need two things. I need 2 and a 5. Which one comes first? The 2, yeah. That matters though. I know it seems like it's not a thing, but trust me, if you put them in the wrong order, bad things happen. So here's 2, here's 5, and I should plug something in. How about 0? Let's plug in 0. What happens when we plug 0 into that fraction? Five minus 0 over 0 minus 2. I get positive over negative, which is negative. So we got minuses up in here. Both of these are linear, so we get 2 sign flips. So minus to plus, plus to minus. Now I can solve the problem, right? What's the solution? Solution set equals minus infinity to 2, unioned with 5 to infinity. And this one's nice. I don't even have to think about whether or not I'm missing numbers to include, right? Because it's a strict inequality. We're not including equality, so like all the critical numbers are out because we're not interested in it being 0, and of course we're never interested in dividing by 0. So.
Excuse me.
Yep.
If 5 is positive over there, then how come the left side is not negative 2? The left side
Because
is...
it would,
Because x is
yeah,
negative.
because negative 2 minus 2.
I mean, you can look at this as minus parentheses x minus 5 over x minus 2 if you want to make it look the same. That's why they're both positive. It's the 5 and a 2. The question, Michael, is what makes the factor be 0? That's where the critical number is, okay? That's good? Yes? Ah, that's a wonderful question. So the graph of this, which we'll be talking about, would be something like y equals to, what was it, minus x minus 5 over x minus 2. So if I look at this formula, I can see that for really large values in the positive or negative direction, it goes to like -1. So like this thing's got like a horizontal asymptote of like -1. That's its horizontal asymptote. The vertical asymptote is where you've got division by 0. So that's at 2. So the vertical asymptote is something like here. X equals to 2 is a vertical asymptote. And then what? Where does it have an x-intercept? Well, the x-intercept is at, well, 5. So that's about here-ish, all right? And so what's the story? It's negative to the left of 2, which means it does this. It goes into the horizontal asymptote like kind of like that. And then up here, goes through my x-intercept and then out like that. So the answer to your question, why do we have to consider the critical numbers in the denominator, is ultimately answered by the fact that if we look at the graph of a rational function, there's 2 places where it can change from plus to minus. It can either change from plus to minus at like a x-intercept, which is where the numerator would be 0, or it can change from negative to positive at a vertical asymptote, and those are coming from where the denominator is 0. So those are the 2 things you got to watch for.
Interesting.
Over here? You want me to graph this? No. What? The numbers in the denominator weren't in the solution set, you say? Oh, but they were. Like this -3 appeared in the solution set, right? That was from here. And the 0 was from here. That appeared in the solution set, right? Right? They were part of the story.
Oh, I think she's just asking why is the ones over there included, like the ones.
Oh, the ones that are included are always coming from the factors in the numerator, not the denominator. The ones that are included make it 0. The parentheses mean excluded. Those are not part of the solution. That's the difference.